Hi everybody, it's Steve Smith, aka Ardalis. In this quick video, we're going to take a look at how to use ChatGPT along with pair programming to practice your pair programming skills when you don't have a human to work with. Actually, it does a pretty good job, so we'll see in just a minute. The other cool thing about this is I didn't even have to use an IDE. In fact, the first time when I was playing with this, before I recorded this video, I did it all on my phone. So you don't even necessarily have to copy paste code when you're doing this. You can pretty much just tell ChatGPT what it is you want your side of the code to look like, and it'll handle it for you just as if you'd written the code to yourself. If you do like this, I'm planning on doing a lot more of these videos in the coming weeks and months. So go ahead and like the video, subscribe if you're interested in more content like this, and let's go ahead and get started. All right, I've got a new chat session here. I've set it up to use GPT-4. It's going to limit us to 25 messages every 3 hours at the current throttling, but that shouldn't be a problem for us. So the very first thing that I like to do when I start working with ChatGPT is basically tell it what it is. Tell it who it should be acting like. You can tell it to be a novice developer. You can tell it to be a student or a child. You can tell it to be a pirate. You can tell it to emulate some real person. In this case, I just want it to be an experienced C# developer. So I'm just going to tell it, you are an experienced C# .NET developer. You know TDD, testing, etc. with XUnit. And you've done pair programming before. Now, my plan is to use a technique called ping-pong pairing, and it's been around for a long time. I would explain it to you, but I have a sneaky suspicion ChatGPT is going to do that. So I'm going to say, I'd like to do a kata with you using the ping-pong pairing approach. And I'll try not to talk while I type. All right, so this is a live recording of ChatGPT. It's hard to script these because every time you work with ChatGPT, you get a different result. But ChatGPT comes back and says, I'm glad to hear you're interested in practicing coding kata. That should be a coding kata, using TDD and pair programming. With the ping pong approach, one person writes a failing test and then the other person writes the code to pass that test. After the test passes, they then write the next failing test and the roles swap. And it's scrolling away, so I'll continue back here. This process continues back and forth. Just as a note, my current functionality is more focused on guiding and providing advice rather than writing and executing real-time code, but let's get started. Let's say we're working on a simple calculator. Here's a test that could start us off. So right away, I kind of have to guide the chatbot right back to where I want it to be, because this is not the actual exercise I want to do. So this test assumes we have a calculator with an add method. Probably it's trying to do the string calculator kata. I thought we'd start with something a little simpler, so I'm going to tell it that. So I thought we'd start with something a little simpler like the FizzBuzz kata. Do you know it? Can you start us off with just the first test? Sure, FizzBuzz is a popular introductory kata. In this exercise, you typically write a program that prints numbers from 1 to 100. But for multiples of 3, print fizz instead of the number, and for multiples of 5, print buzz, and for multiples of both 3 and 5, print FizzBuzz. Here's a starting test case for FizzBuzz, and again, it's using XUnit. It's given us a class called FizzBuzzTests. Get output, number is 1, returns 1. Looks great. In this test, we're checking that when we input 1 to the getOutput method, and that's not the same method that it used last time I tried this, we expect to get the string 1 as output. This test will fail until you implement the FizzBuzz class and the getOutput method. All right, my turn. All right, so that's my turn. So I go ahead and I implement a FizzBuzz class with a getOutput method. I tell it accepts an integer, has one line of code that returns a 1. That test now passes, the test that the chatbot wrote for me. So now I write the next test, and we're operating under the principle of doing the very smallest thing that can possibly work when we're doing TDD. You don't want to jump to a generalized solution too quickly. Sometimes you'll end up doing more work than you need to. So in this case, we aren't going to refactor our code until we see that we need to. And so even though we probably know that we could just say return, number.toString, and that would work for many different test cases, we're going to return literal values first, and then we'll force ourselves, once we have more tests, to go in a more general direction. This is something that Uncle Bob has described as a principle that when the tests start to get more and more specific, the system that you're testing has to get more and more general. But it should start out being very, very focused and very specific. All right, so ChatGPT is going to do a new test, and this one it's going to actually test the number 3. So we're pretty much just working in order of inputs 1, 2, 3. But 3 is different because it is a multiple of 3, so we expect it to give back fizz. And of course, this checks that the chatbot says this test checks that the method returns fizz when the input is 3. The test will fail as currently get output method doesn't handle this case yet. Your turn to implement. All right, so here we go. All right, so I'm just going to add another if statement, and if the number is 3, I'm going to just immediately return fizz. That's going to pass the test that the chatbot is adding. So we're going to now test number 4, because why not? We're just moving in order. 4 also is not a multiple of 3 or 5, so we expect it to just return 4. But this is going to get us to the point where we really ought to start refactoring. I pretty much follow a 3 strikes you're out rule with regard to duplication. And so when I see the same thing happening in 3 places, that's a trigger for me that I really want to think if there's a way to refactor that. So we'll see if ChatGPT remembers that TDD should be red, green, and then importantly, refactor. Sometimes it will consider that it's time to refactor, sometimes it doesn't. So we'll see what it says. All right, now I'm going to use XUnit's inline data attribute so that all of the non-matching numbers can just be passed in with attributes. But I don't have to write that code. I don't have to know about the theory attribute or any of that. I can just tell ChatGPT that that's my intent. So you can see here the chatbot says, sure, we can use inline data to simplify our test cases and avoid code repetition. Here's how the test class should look now. And the important thing to note here is that we've now got a theory for our regular numbers, and it returns the number as a string. Notice that ChatGPT already renamed the test for us, so it's given it a more generalized name, and it's basically showing that each one of these numbers should return the expected result of itself as a string. And then we still have the other, if the number is 3, it returns fizz. So ChatGPT is telling me in the theory with inline data attribute, we're specifying multiple sets of values to test the get output method with. In this case, we're testing numbers 1, 2, and 4 and expecting them to return the strings 1, 2, and 4 respectively. Really, you wouldn't even have to pass those values. You could just say that they, return themselves .toString and put that in the test. But this isn't wrong. It just is slightly more verbose. It says, your turn to make the tests for 4 pass and write the next failing test. No, it's not. I wrote this test. No. I wrote the test for 4. I just asked you to print it out. Now you can implement the code for it, please. All right, so if I were having a real test partner, I wouldn't be asking them to refactor the code for me and write it out. In this case, I did so that I don't have to write the code. But since ChatGPT can't put up a fight, I'm going to just remind it that, no, testing number 4, that was my test. You've got to implement test number 4 because it still failed. All right, so I apologize for the confusion. It says, given your implementation that checks for 3 and returns fizz, we can generalize this to return the number as a string for non-matching cases, 1, 2, 4, etc. Here is the updated get output method. So it's going to just front load the check for fizz, which I think we're already doing, and then we're going to return number.toString. Now, again, we could have done that at the very beginning, but then we would have been writing a bunch more test cases for things, and they would have just been green from the start, right? And you can't really do red, green, refactor if it's just green, green, green. The other thing to point out is that they went ahead and basically refactored the solution. So they did 2 steps here in 1. And so I could push back and say, well, wait a second, you kind of did a little bit more than you needed to. Let's do this step by step. Now, for something this simple, I wouldn't worry about that, but I do want to see how well ChatGPT responds to that. So I am going to push it a little bit here. All right, so I'm going to remind it that we really want to go in baby steps, do the simplest thing that could work, add one more if check, even if it means there's some duplication, and then we'll refactor it. So now it's going to show what the duplicative code would be, and it's actually, I think, screwed this up, so we're going to have to help it out a little bit. Now it says, you're absolutely right, I apologize for the oversight. Following true TDD principles, we should only implement just enough to make the failing test pass. We shouldn't assume future requirements or overgeneralize too soon. So for the failing test case with input 4, the simplest implementation is indeed adding an if statement for that. Here's how that would look. Notice we're checking 3 and 4, and we are going to return 1. So we have 4 test cases, 1, 2, 3, 4, and I only see 3 of those implemented here. So I think he's introduced a bug. Now, ChatGPT says, now all existing tests should pass. Your observation about possible refactoring to handle all non-fizz numbers in a more general way is very perceptive, but we should only address that when a test case necessitates it to avoid speculative generality. Thanks for reminding me about the importance, etc. So I'm going to tell it, I don't think your code is quite right. What would happen with test case 2 now? And he says, you're right, I provided would fail for test case 2. I neglected to include the if condition when the input is 2. So here's the correct implementation following the principle doing the simplest thing to make the test pass. And now we finally see we have 2, return 2, 4, return 4, otherwise return 1, and return fizz. And here we can see the duplication that kind of makes it clear that it might be time to do some refactoring. So hold on, we're doing red, green, refactor. We just got to green. So now is the time to do your refactoring to generalize. Let's see if that's enough for it to go back to where it was. Yes, you're absolutely correct. ChatGPT loves to tell me I'm correct. If you have a pair programming partner, it's great if they just say that you're right all the time and don't ever like tell you you're wrong. So aside from being a little bit too much of a yes man, the ChatGPT does do a pretty good job here. So following your red-green refactor cycle, now is indeed the appropriate time to refactor the code to make it more generalized. We can simplify our getOutput method by checking if the number is 3, and in all other cases, we simply return a number as a string. Here's the refactored implementation, which looks a lot like what we had before. And yes, this should now pass. So it is my turn to write the next. Actually, no, it's ChatGPT's turn. Okay, now that all tests are green and our code looks good, Chatbot should write the next failing test. So it's going to do number 5, which is the next number in sequence. It should return buzz. It's a very simple test. Now it's my turn to make it pass. I'm going to add another check to see if it's 5. If it is, return buzz, just like we did with fizz. That should pass this test. All right, so I'm going to add a new test for the next number, which is 6, and we're going to use theory and inline data and refactor the test we already have. I don't actually have to refactor it. I'll let ChatGPT do that. The thing is, if you're doing this on your phone or some other device where you don't have an IDE or even a keyboard, it can be nice to just kind of let the chatbot generate the code for you for the test that you're writing. In this case, you can see that it's now saying that if it's a multiple of 3, it should return fizz. It's got 3 and 6. Test will fail. It's your turn to make this test pass. No, it's not. That's my test. Again, we'll be polite about it, though. No, it's not. That was my test. You can implement it, please. Following the test you've written, I'll implement the change needed to make it pass. In this case, I'll add an if condition to check whether the number is a multiple of 3. Here is the updated get output. So now again, we're going to become more generalized. We were saying if it's equal to 3. Now we can say if it is a multiple of 3. Right? We're not really following the 3 strikes you're out. We could have done another if check for 6, and then only when we get to 9 do it. But in this case, it's pretty clear where we're headed, so we can do that. That looks good. So this should make the test for number 6 pass, correct? Yay. Sometimes you have to remind ChatGPT that it's its turn to write the next test. We're going to try 7. Should just return 7. Here's a failing test. This will initially fail since getOutput method currently doesn't handle the case for 7. Now, again, I don't think ChatGPT is right here. Let's look at this. I'm pretty sure if I pass in 7, it's not going to be a multiple of 3. It's not going to be 5. It is going to return number.toString. So sometimes it is useful to add additional passing test cases. This is really easy to do, especially when you're using theory with inline data. So rather than having a whole other test here that's, 2 lines of code, but actually like 5 or 6 lines of text, I'm going to suggest that we just put that in with our existing set of test cases for non-multiple inputs, and 7 being prime is of course not a multiple of 3 or 5. ChatGPT seems to be stumped by this, so let's see what it does. Maybe it's going to error out, or maybe I've done too many inputs already. And it timed out. Network error. Let's regenerate. You're correct. I apologize for the oversight. In our refactoring stage, we had generalized the getOutput method to return a string representation of the number for all inputs not divisible by 3 or 5. So you're right. The test for 7 should indeed pass immediately. It was my mistake to suggest it as a new failing test. Given this, we should proceed to the next unique FizzBuzz case, which would be for multiples of 5, namely the number 10. Here's the failing test for that. Looks great. This test will fail. That is better than a network error. It's my turn to make the test pass. All right. Well, 2 things. We're in a failing state. We're in a red test state. All right. So I'm going to tell it that I'm going to just modify the if check to, instead of being equal to 5, use modulo 5 equals 0, which is how you test for divisible by 5, and that should make this test pass. And then I suggest that we can get rid of duplication in the test. ChatGPT says, absolutely, that's the correct approach. With the modification you made, the test for 10 should indeed pass. Refactoring the test is a good idea. Just as we did for the fizz test, we can consolidate buzz and use the inline data attribute on a theory. And it looks like this. And it looks right. This test checks that getOutput method correctly returns buzz for multiples of 5. With the refactoring complete, we should write the next failing test. Who's we? The next special case in the fizzbuzz sequence would be 15. We should return, I'll leave that to you, following our ping pong approach. That's right, it's my turn. So I'm just going to write a test, returns fizzbuzz when it's 15, and let chatbot implement it. Great, you've identified the next special case in our sequence. I'll now implement the change needed to pass this test. We need to check if the number is divisible by both 3 and 5. Here is the updated getOutput method. If number %3 equals 0 and number %5 equals 0, fizzbuzz, otherwise everything is the way it was. This implement checks if the number is divisible by 3 and 5, and if so, returns fizzbuzz. If not, checks for 3 for fizz and 5 for buzz. For all of the numbers, it returns numbers of string. This should make the test pass for number 15. Now, you might notice a bit of a pattern here. Each of our unique cases are identified by their divisibility rules. Given our refactor stage, you might consider whether these tests could be further consolidated. But for now, your turn to provide the next test. I'm going to ask it, tell me more about how you would consolidate these checks. Certainly, I see 2 main ways we could consolidate our tests. I wasn't talking about the tests. Combining into one theory test. Oh, I don't like that at all. We could have one theory that covers all of the fizz, buzz, and fizzbuzz and number of string cases, like so. That is horrible. GetOutput test cases. If that test fails, you have no idea what went wrong. This allows us to add new test cases quickly with just new inline data entries, or separating by type of output. However, you might argue that the above is less clear in terms of what each test is specifically checking. Yes, indeed, I would. Another approach would be to have separate theory tests for each type of output, fizzbuzz, and number as string, but to include all relevant cases in each. Yes, that's exactly what we are doing. So here are the multiples of 3, here are the multiples of 5, here are the multiples of 3 and 5, and then the others. This gives us clear separation. Each has its own trade-offs. The best one would be just an asset. I have a strong preference for the latter. All right, so I'm suggesting we add an inline data 30 to the multiple of 3 and 5 test, and it's going to just pass because we already used a generalized approach there. Chatbot says it's a great choice. Keeping the test separated by the expected output, we ensure that the intention of each test is clear and it's easy to see the cases being tested for each output type. Exactly. To add 30 as another test case to the fizzbuzz outputs, we can update the test like this. This new test case should pass right away with our current implementation, as 30 is a multiple of both 3 and 5. It's good to verify that our code is correctly handling other multiples of 15, though. Your turn to add the next failing test. All right, so at this point, in order to complete the fizzbuzz kata, we're supposed to write out the numbers from 1 to 100 and replace their values with fizzbuzz or fizzbuzz. I'm not going to drag this video out anymore showing that, but hopefully you've seen that with a little bit of guidance, and just like any junior developer you might have to guide, ChatGPT acts as a decent pairing partner. And in fact, for times when you don't have access to writing the code yourself, you can let ChatGPT help you by generating the code, both for the tests and for the implementation code. And in fact, if you're working in a language that you're not familiar with, you can use ChatGPT for that purpose. In fact, let's just demonstrate that real quick. Hey, let's say I didn't know JavaScript, but I wanted to learn it. A great way to do that is by doing a kata like this, and you don't necessarily have to know the perfect syntax. If you already know what the code should do, and you just want to translate it into the idiomatic code of the language that you're trying to learn, whether that's JavaScript or Python or Java or Swift or Rust or whatever it might be, you can work with the chatbot to do that as well. So since we already did all the work of generating all the tests in C#, I can just ask it, let's say I know that JavaScript exists, and I know that Jest is a test library for it. I can just ask it to do the same work that we did, but using that stack. And as you can see here, ChatGPT does a pretty good job. Absolutely, I can provide a similar test structure using JavaScript and Jest. We'd need to have a function like getOutput in a module that we could import into our test file. Here's a simple starting point with our implementation, and then it's going to export getOutput. And then here are the Jest tests, which mirror the ones we wrote in our C# implementation. We have fizzbuzz.test.js requiring fizzbuzz to get that module, and then running each of those tests, doing essentially the same inline data style that we had before, and checking each one of these with multiple inputs for each test case, and essentially doing the same type of logic for these unit tests that we did in C#. Just like in the XUnit test, we have one test for each category of output. We're using Jest's test.each utility to easily test multiple input cases for each output category. So I didn't necessarily have to know that test.each was a thing. It's a unique syntax for Jest, and it has nothing to do with how XUnit does it, but ChatGPT knows, and so it's able to do that translation for me. It even tells me how I could run these tests. I can run them at the command line by just saying jest fizzbuzz.test.js, and all the tests should pass with the provided implementation. I'm going to trust it on that for now. It looks right to me, but I'm going to go ahead and wrap up this video. So thanks a lot for watching. Again, like and subscribe if you want to see more videos like this, and keep on getting better.